Hey guys, this is Miss Gephardt, and we're going to go through the oceans overview notes, so make sure you have out your notebook and you're ready to take down some notes. When you finish these notes, you should be able to answer these essential questions. So first off, understand kind of an overview of what is contained in the ocean, and I'm meaning more specifically like the water itself. And second, what are some features that make up the ocean floor? All right, so first thing to talk about, and something we've already probably pretty much covered when we started with freshwater, but the big thing to understand is when we look at the planet itself, ocean water covers much of the Earth, so about 70% of the Earth's surface is covered with ocean water. Now, of course, we all know that you're not drinking any of that ocean water. It's highly salty, so nothing that we would get anything from, but just as that general fact, it's 70%. Ocean water contains a lot of salts and gases. And first thing to understand what a salt's going to be coming from the earth itself. So we have to imagine that mountain areas and land areas that have weathered over time, broken down, and then been eroded away. And the breaking down of the rock and such is making up these salts. Okay, so there's all different kinds of salts. You probably are the most familiar with NaCl because that is the salt that you would this is the salt right here, NaCl, sodium chloride, which is what you would have on your fries or whatever. But there's all different types of salts, okay? And so the ocean contains these salts. Salinity, this word right here, salinity is a measurement of the amount of salt present in a body of water. Now understand what that means. The ocean is not uniform the same amount of salt. So just because I go off to Wilmington and I take a sample and I measure its salt, and then I go to Antarctica and I go to the Philippines and I go to Alaska and Hawaii, the salt amounts are going to vary. So just remember that ocean doesn't mean it's the exact same amount of salt. So, and we'll talk about some reasons why the salt amount would change, but just be familiar with the term salinity. Now, the most common salt is the NaCl. So do understand that to be the most common, but know that there's other types of salts present. All right, so now another term, and this is something that you have been introduced to already, and it's still going to come back up. We're still in water. Density. So the measurement of the amount of matter packed into a given volume. Now, how does that relate to the salt water? Well, what you see right here, this is the Dead Sea. Okay, and as you can see, this gentleman is just straight up floating. There's nothing underneath him holding him up. He's just chilling in the water. And you can see he's very close to the surface right here. That is because the Dead Sea contains so much salt, it causes the person to be that less dense. Does that make any sense? So he is so less dense, he's pretty much being pushed straight up out of the water. Not out of the water, but pretty much as close as he can. If we were to put this guy in a freshwater river or lake, he would sink more because it doesn't have the salt concentration. So salt changes the density of the water, making you less dense, makes you more buoyant, makes you able to float higher, so to speak. So higher water salt content equals a higher density. So kind of just be familiar with that. Now, salt amounts are going to vary, and there's going to be all different kinds of reasons why salt amounts vary. One reason that we might have salt amounts varying, if we look right down here, right here. Okay, if we have a freshwater river running into the ocean, we're going to get a whole bunch of fresh water in salt water, and so it's going to be diluting the salt water. So think about if I gave you Kool-Aid, and I gave you a glass of Kool-Aid, normal Kool-Aid, and I poured a whole cup of water into that glass. Now that Kool-Aid is very dilute. It's going to be kind of, it's going to taste like maybe cherry, but it's going to not be as strong of a taste. It's going to be kind of a weak flavor. Same idea with the water. So if the fresh water comes into salt water, it's diluting it, so it's not quite as salty. Another thing that might lend to less salty water is cold conditions. Salt doesn't freeze. So if we're up in the Arctic, all of this water, once it freezes, the salt's going to remain behind. So this water could be saltier, potentially. Another reason, if we had an excessive amount of rainfall, so a whole bunch of fresh water diluting the salt water is going to get us a different amount of salt. It's going to be less. A last thing that we could find is temperature. So think about the equator. in the sense that the equator is very, very hot. So the equator is going to cause lots of evaporation to occur. And when that evaporation occurs, all we're going to get, so when we get that evaporation, all it's going to do is it's going to suck up the fresh water, leaving the salt behind. So we could expect to see in areas of the world up in like about the equator, we're going to expect to see higher salt content. So up in the polar areas, we'll also see higher salt content. So just know you can't walk out to the beach and assume that the water or the salt amount is going to be the same regardless. Okay. What this is this is some of the salt formations at the Dead Sea. So you can see there's once that water leaves, this is all salt crystals. This is all salt that's left behind. So when you have the evaporation occurring, the salt's going to be left behind. And because the Dead Sea is so salty, it's been so much earth has been weathered and eroded into this sea, it leaves behind a whole mess of salt. So, and yes, probably if we went over there and crack this little hunk off and gnawed on it, it would taste like salt. Make sure I got it right, sorry. All right, so the next thing, ocean is going to contain gases too. So we talked about the salts, now we're going to talk about the gases. Oxygen is going to be the primary gas that's involved that we find in the ocean, but there's also all the gases that make up our atmospheric gases, so nitrogens, things like that, other gases that are going to be involved. But big to understand is the oxygen, because obviously the fishies needed to breathe and the other organisms living in there needed to breathe. Dissolved gases are going to be very essential to ocean life. That's why we've got the animals and the organisms that are able to live in there, because of the oxygen in the water. Ocean temperatures vary, and that makes sense. Up here at the surface, this surface layer is going to be warmer, okay? And as we move down, we're going to hit, and the surface layer is going to be warmer just because it's heated by the sun and the sun and the wind. The thermocline right in here, this is kind of like this before the major drop-off occurs. In this area, because we're getting further and further away from the sun, the temperature just starts to drop kind of quickly, and then we hit deep water where it's always going to be cold year-round, because there's no way it's going to penetrate any kind of sunlight, so it can't really keep it warm. All right, and you can kind of tell in here, this is where the warm sections are going to be, right around the equator, and it's going to get progressively colder in terms of surface temperature as we work our way away from that. All right, finally, the last thing to talk about are the features of the ocean floor. This is probably not the first time we've seen this, but we start off with the shelf, which is right here. All right, then we've got this sloping downward, a continental slope. So we have a shelf. Think of a shelf at your house, then a slope, which is a pretty steep decline, okay? And then we've got this abyssal plain, so this just a plain, flat area. Other features that we want to note are trenches. Trenches are very deep. Something like the Marianas Trench can go down 10,000 feet. So very, very sharp trenching, very deep trenches. And another thing to look at is something called the mid-ocean ridge. This is where the plates are actually going to be shifting. So the magma pushes up and then shoves the earth in these directions. So that's the mid-ocean ridge. And there's actually one that goes right down the center of the Atlantic Ocean. It kind of looks like one of the scars on Frankenstein. Like that kind of has this look like this. But it goes straight down, and that's the mid-ocean ridge, and it's actually what's causing the Atlantic to start widening. If you have any questions, please make sure you see your teacher. If you don't understand any of these features, do go back and review them.